Hello, everyone. It's a great pleasure to meet you. I'm truly honored to join you here. I wish to express my sincere appreciation to LGU Plus for this wonderful opportunity to be a part of the Orange Global PlugFest Spring 2024. I'm Dallin Junt from Accuver HQ, a world's leading mobile network test solution provider. Since 2022, Accuber has been actively participating in Oren Alliance activities on behalf of its headquarters in wireless. Now, I'm going to introduce our solution to validate frontal interoperability in this presentation. Today's agenda includes the following topics: testbed setup, working group for IoT test results, and then I'll conclude with our strengths. Let us begin with testbed setup. This page shows the logical architecture. You can see EasySo in the left. EasySo is the product name of our solution for ORAN. It collects real-time traffic data from the interfaces of RU, DU, and CU and performs detailed analysis of each interface and protocol. EasySo collects and analyzes the CUS planes and encrypted endplane traffic of the open frontal interface between RUs and DUs using tab equipment. EasySo is interworking with Xscale, which is a mobile-based network data measuring solution, and XCAT IXA, which is a spectrum analyzer. As a result, we offer a comprehensive ORAN test solution portfolio that covers three main areas: Working Group 4 IoT, Working Group 5 IoT, and TIFC E2E test. In this PlugFest, our solution was used to validate Working Group 4 IoT. Let's take a look at how we set up. We configured the testbed with VVDN-RU and Korea third parties DU and CU. Application test server was also provided by Korea third party. The DU and RU were connected with 10G optical cable, and all frontal traffic were collected using TAP. The XCAT IXA, a spectrum analyzer, is connected to the GPS antenna, measuring the RU time offset and frequency offset by analyzing the RU signal. EasySo is configured to work in conjunction with Xscale. The role of Xscale is crucial as it manages the automated call of devices, collects and stores logs, and transmits the RRC messages necessary for the IQ analyzer to perform channel decoding. This is system configuration descriptions for test environment. This table shows the parameter setting value between RU and DU. These parameters must be set in EasySo in advance. If the setting value is correct, then EasySo can perform correct KPI calculations and channel decoding of IQ data. In this PlugFest, we conducted the Working Group for IoT test. The version of the standard referred to is version 10. Let me explain the test results of MSCU planes in the next slides. As you know, Working Group 4 IoT has 23 test items. Out of 23 items, we conducted a test on 7 items, 1 for M planes, 2 for S planes, and 4 for CU planes, and all the 7 items were passed, as you can see in the table. 16 items were not tested because the test environment is not configured and the test cases are not defined in the standard yet. This is the test report. After completing the test, EasySo provides a batch report automatically in the format defined by the ORAN Alliance. It shows the time the test was conducted, the number of the test cases executed, and the test results, pass or fail. Let me show you 7 test items from now on. The first one is startup in hierarchical mode in M-plane. Frontal Protocol Analyzer is used to verify M-plane flow and message contents. In this PlugFest, RU and DU netconf was encrypted by a secure shell, so end-plane message could not be confirmed through captured packets. During the test time, wireless parameter values are received from Xcal and netconf command is executed to RU directly to acquire parameter values. You can see the log in the left is the XCAR DM data, including PCI, bandwidth, SCS, and MIB values. And the table in the right is the log of EasySO and the detailed report results. Since the value received from Xcal and the value received from RU were the same, this test was judged as a pass. The second one is functional test in S-plane. The purpose of the test is to ensure that the DU and RU that received signals from the PTP grandmaster are time synchronized. EasySO can check the sync state change and PTP synchronization of RU and DU under the three conditions: startup, nominal, and degraded. After the test restarted the RU, EasySO checked the PTP sync state change of the RU through the netconf command. In the EasySO log, you can monitor the PTP sync state changes of the RU over time. The table in the right is the data report and CDR data generated by EasySO. The following test item is a S-plane performance test in LLS C1 environment when two RUs are linked to one DU. Spectrum Analyzer XCAD IXA was used to measure the radio interface of RU. The image in the left is a screen capture of XCAD IXA, including time offset and frequency offset. EasySO periodically receives data from XCAD IXA, so it calculates the relative time between two RUs. The standard value of category B is that time offset is within plus minus 260 nanoseconds, so the test was passed. The next test item is performance and interoperability in the CU plane. It's a test to validate DU and RU wireless system capabilities, performance, and interoperability using the frontal interface. EasySO can run a predefined autocall in conjunction with Xcal to verify control plane settings and user plane data transmission through call setup. Xcal records radio layer 3, RRC, NAS message flows in a log, and receives a response to a ping request sent by UE to the application test server, 10 IP packets of 32 bytes. So the test was judged as a pass. The next test item is radio uplane downlink data transfer. In this test scenario, we need to test whether UE can perform radio uplane data transfer also with the network through RU and DU. In Xcal, a predefined automatic call is executed to test downlink throughput, and then EasySO can get data from Xcal. The image in the left is the log when the downlink throughput test was conducted using 4 layers and 256 QAM. In the right, you can see that measured throughput is about 1085.948 megabps, and the target data rate is 1000 megabps, so it was passed. The bottom right, you can also see that EasySO provides a report in graph. The next test item is radio uplane uplink data transfer. The test was conducted in 1 layer and 64 QAM environment, and the UL throughput was measured at 42.851 megabps. As the result was higher than the target data bitrate 40, it was passed. The last test item is delay management in the CU plane. Since EasySO cannot measure the time between RU and antenna, the latency of packets between the RU and DU was measured. As you can see the picture in the left, two taps were installed between RU and DU, and the test was conducted by changing the cable length between taps. When the distance between taps is 2 meters, the latency average was measured to be about 19 nanoseconds. And when the distance is 10 kilometers, it is about 50 microseconds. In EasySo, identical packets can be checked using a tool called Accuver, and the detailed report provides a graph on the latency of packets. Let me summarize our strengths. With EasySo, we can monitor and analyze real-time packets for front haul, middle haul, and backhaul interfaces. Also, our solution provides a complete lab ORAN test solution portfolio of the following three parts: Xcal, a mobile-based network data measuring solution; EasySo Protocol and IQ Analyzer; and XCAD IXA, a spectrum analyzer. Xcal monitors UE trace. Protocol Analyzer collects traffic and acts as a process role, and IQ Analyzer processes IQ data to decode radio channels and provides resource block map. Spectrum Analyzer measures the time and frequency offset of the RU. With this portfolio, we covered TIFG end-to-end test and Working Group 5 IoT, as well as Working Group 4 IoT so far. Accuver also provides automated feature for IoT and E2E testing, a pivotal step for the complete and successful implementation and commercialization of the ORAN solutions. Let me give a short demo. This is a video recording of a test for radio U-plane downlink data transfer among the CU plane test items introduced earlier. At first, you can set OTIG info and vendor info for batch reports in batch setting stage. You can also set target data rates of downlink. When you run a test, EasySo controls Xcal to run autocall, and you will receive data from the FTP server. EasySo records the throughput values from Xcal every second and outputs the data in the report automatically. This automated testing offers significant advantages in terms of ease of use and time efficiency. In conclusion, all the mentioned functions are provided through useful and simplified GUI. Also, you can elevate your efficiency with our automatic report generation function, designed to streamline your workflow and deliver precise, comprehensive reports with the click of a button. That's all I prepared for our presentation. Once again, Accuber sincerely thanks LGU Plus and our test partners for the outstanding collaboration in this PlugFest. Thanks for having me.